Dear students, welcome to the lecture series on power system analysis. Today we will be extending the analysis that we have done for single machine system to multi-machine systems. So we have already derived the equation for swing equation for a single machine and infinite bus system, and this particular result can be extended for multi-machine system. In a practical power system, the machines are multi-machine in nature. That is, system is multi-machine. You will have multiple machines, and these machines will be reacting to the disturbances that occur in the system. So how such a multi-machine system can be represented using the same swing equation that we have derived for a single machine system that we will be seeing. Now G machine is the machine rating or the base MVA for the machine, and G system is the common base MVA for the system or the system base. Now this is a swing equation where M in per unit can be written as h by f, where h is the inertia constant. H by f is into d square delta by dt square is equal to Pm minus Pe. Now G, so you are multiplying this equation with G machine by G system on both the sides. So you will be getting an equivalent equation like this: H system by pi f into d square delta by dt square is equal to Pm minus Pe, where H system is equal to H machine into G machine by G system. So here you have converted the inertia constant of the machine into inertia constant of the system, common system. So you have converted your swing equation, which was given for the machine rating, to the system rating. Initially the swing equation was derived based on the machine rating, that is for a single machine. Now you have converted that to a common system or common base. Okay, so this equation represents the swing equation in a common system base or a common base MVA. Now this is the inertia constant in common base MVA. Now what happens when machine swings coherently? That is, when a disturbance occurs, the delta will be varying in same manner, or change in delta will be same for the machines. Delta will be varying together. Delta as well as change in delta will be same. So that machine is swinging together. So such a condition is known as machines swinging coherently. They are swinging together. The delta variation will be same in different machines. So in such conditions can occur in power system. In such conditions, what we do is that for analysis purpose we will be deriving another equation. Now, as we have done in the earlier case, we have converted this particular equation to a common base, h1 by pi f into d square delta 1 by dt squared is equal to Pm1 minus Pe1. For this is for machine 1. Okay, so this is for a common base. H1 has been derived based on common base. So earlier we had got an equation for H equivalent or H system. Okay, so that H system is same as H1 here. Okay, so H1 you have derived based on that. Similarly, H2 is defined for another machine. This H2 is also derived based on H system equation. Okay, based on its own rating, you have converted it to a common rating. Now, once a machine swings coherently, you can consider your delta 1 equal to delta 2. So adding the equations together, you are considering your delta 1 equal to delta 2 equal to delta, and you are adding the equation, you will be getting h1 plus h2 into d square delta by dt square is equal to Pm1 plus Pm2 minus Pe1 plus Pe2. So this can be written equivalent to this, and this can be taken equivalent to Pe, and H equivalent will be h1 plus h2. So that you can further derive out of your earlier equation. Okay, H machine into G machine, G1 machine by G system plus H2 machine into G2 machine by G system. So this equation we have derived in the first part, and you combine them together to get the total H equivalent. Okay, now we will take an example. You have two machines swinging coherently, and the rating of machine is 100 MVA and H is 2 per unit. And for machine B it is 150 MVA and 1.4 per unit. So you need to find out the inertia constant in per unit for the system for a common base of 200 MVA. So HA is given as 2 per unit at 100 MVA and HP is 1.4 per unit at 150 MVA. So you are converting it into 200 MVA. So it will be 2 into 100 by 200, that is 1 per unit, and HP will be 1.4 into 150 by 200, that will be 1.01 per unit. So the H equivalent will be H1, HA plus HB, which will be equal to 2.05 per unit, which is defined for a 200 MVA. Okay, for 200 MVA base. Okay, so this kind of question you will be getting for gate examinations generally. You can get this question for say 5 marks for part A also for your university examination. Okay, so thank you.